As the human body advances in age, a profound and intricate transformation occurs within the vast network of blood vessels that sustain life, an evolution frequently characterized by a progressive loss of structural elasticity and the insidious, silent onset of arterial stiffness. This vascular senescence is not merely a superficial or inevitable decline but a fundamental deterioration of the deep physiological infrastructure that dictates systemic health, cardiovascular endurance, and physical mobility, particularly concerning the peripheral extremities such as the legs and arms. At the very core of this age-related vascular metamorphosis lies the endothelium, a delicate, single-cell thick lining of the blood vessels that serves as a highly active metabolic, sensory, and endocrine organ, rather than a simple inert barrier separating blood from tissue. In the vitality of youth, the endothelium masterfully orchestrates vascular tone, expertly balancing the opposing forces of vasoconstriction and vasodilation to ensure optimal blood flow to every capillary bed in the body. But decades of cumulative oxidative stress, systemic low-grade inflammation, and metabolic wear and tear invariably precipitate a condition known as endothelial dysfunction. This dysfunction represents a pathological state where the blood vessels stubbornly resist relaxation, heavily favoring a state of chronic constriction that severely limits the delivery of oxygen and vital nutrients to peripheral tissues. This localized impairment is severely compounded by the relentless progression of arterial calcification, a complex biochemical process wherein calcium phosphate crystals pathologically deposit within the medial layer of the arterial walls, effectively transforming what were once supple, living conduits into rigid, unyielding physiological pipes. Consequently, the elderly frequently suffer from chronically constricted peripheral arteries, a condition that manifests as diminished blood flow to the lower extremities, chronically cold hands and feet, muscular cramping known as intermittent claudication during minor exertion, and ultimately, a devastating loss of independent, pain-free mobility. The paramount biochemical protagonist capable of effectively counteracting this relentless stiffening and restoring youthful compliance to the vascular tree is nitric oxide, a seemingly simple yet profoundly powerful diatomic free radical that functions as the primary and most potent endogenous vasodilator in the human body. Originally discovered by pharmacologists as the elusive endothelium-derived relaxing factor, nitric oxide is continuously synthesized within healthy blood vessels by an enzyme known as endothelial nitric oxide synthase, which facilitates a complex biochemical reaction converting the semi-essential amino acid L-arginine into L-citrulline and nitric oxide gas, an event requiring the strict presence of molecular oxygen and various crucial cofactors including tetrahydrobiopterin. Once produced within the endothelial cell, this highly volatile nitric oxide molecule diffuses rapidly across cell membranes into the adjacent vascular smooth muscle cells that wrap around the artery, where it immediately binds to and activates the intracellular enzyme-soluble guanylyl cyclase. This vital activation triggers a massive intracellular conversion of guanosine triphosphate into cyclic guanosine monophosphate, a powerful secondary messenger molecule that acts as a master physiological switch to sequester free intracellular calcium back into the sarcoplasmic reticulum, actively detach the binding of myosin heads from actin filaments, and ultimately compel the tightly wound smooth muscle fibers to relax and elongate. This cascade results in the widening of the arterial lumen, dramatically reducing the resistance to blood flow and allowing a rich, life-sustaining surge of oxygenated blood to penetrate deeply into the starved, ischemic peripheral tissues of the aging body. However, as age and systemic inflammation severely compromise the endothelial production of this miracle molecule, creating a systemic deficit that accelerates vascular calcification, individuals must look beyond the compromised blood vessels themselves to locate an alternative, robust source of this life-preserving gas. A largely overlooked but massively potent source of endogenous nitric oxide resides entirely outside the cardiovascular system, specifically sequestered within the cavernous paranasal sinuses of the human skull, presenting a revolutionary physiological mechanism waiting to be harnessed by the aging demographic. The epithelial cells lining the maxillary, ethmoid, sphenoid, and frontal sinuses continuously express phenomenally high levels of an alternative enzyme variant known as inducible nitric oxide synthase, which operates independently of calcium signaling to generate a localized, continually replenishing reservoir of nitric oxide gas at concentrations that are incredibly high, often reaching parts per million, orders of mouth-breathing magnitude higher than those found anywhere else in the human internal environment. When an individual consciously and deliberately inhales through the nose, the incoming turbulent air current swiftly sweeps through the labyrinthine structures of the nasal cavity, actively drawing this accumulated, highly concentrated nitric oxide gas from the tiny ostia openings of the paranasal sinuses and carrying it deeply down the respiratory tract directly into the pulmonary alveoli of the lungs. Upon reaching the expansive surface area of the deep lung tissue, this sinus-derived nitric oxide immediately diffuses across the ultra-thin alveolar capillary membrane directly into the systemic arterial bloodstream, acting as an instantaneous, highly potent vasodilator that not only radically enhances localized pulmonary blood flow to optimize the ventilation perfusion matching critical for efficient oxygen uptake, but also cascades systemically to reach the furthest peripheral arteries. It is this exact physiological phenomenon that sets the stage for a deeply transformative, non-pharmacological daily practice designed specifically to rescue the calcified, rigid blood vessels of the elderly. To systematically harness this remarkable physiological mechanism to actively rehabilitate calcified peripheral blood vessels, an integrated physical practice emerges, optimally combining deliberate, rhythmic nasal breathing with the gentle, continuous, and rhythmic biomechanics of walking, forging a synergy that forces biochemical vasodilation on a systemic scale. Walking, while seemingly the most basic and fundamental human movement, inherently demands an immediate increase in cardiac output and powerfully initiates the skeletal muscle pump of the lower extremities, a mechanical process where the rhythmic, alternating contraction and relaxation of the gastrocnemius, soleus, and quadriceps muscles physically compress the deep veins, forcefully propelling deoxygenated blood back toward the heart against the pull of gravity. Simultaneously, this muscular demand drives a reflex surge of freshly oxygenated arterial blood downward into the legs, and this exercise-induced increase in blood velocity generates a highly specific frictional force against the endothelial lining of the arteries known as hemodynamic shear stress. This shear stress is not destructive friction, but rather a profoundly beneficial mechanical stimulus that directly acts upon mechanoreceptors located on the surface of the endothelial cells, mechanically signaling them to upregulate the genetic expression and immediate enzymatic activity of endothelial nitric oxide synthase, thereby coaxing whatever functional capacity remains in the aged endothelium to produce localized nitric oxide. The true, unprecedented transformative power of this therapeutic protocol manifests entirely when this internally generated mechanical shear stress of walking is seamlessly and deliberately synchronized with the massive biochemical influx of sinus-derived nitric oxide achieved through strict, rhythmic nasal breathing, essentially attacking the problem of arterial stiffness from two distinct physiological angles simultaneously. By actively inhaling deeply through the nose for a specific counted number of steps, such as 3 or 4 deliberate paces, and subsequently exhaling smoothly through the nose for an equal or slightly longer duration, the elderly practitioner actively forces a continuous, massive infusion of endogenous nitric oxide directly into the systemic circulation right at the exact moment when the exercising peripheral arteries require it the most. This targeted, dual-action vasodilation effectively forces the chronically constricted, calcified peripheral arteries to dilate, temporarily overriding their entrenched structural stiffness through sheer biochemical willpower and the overwhelming presence of the nitric oxide molecule. Over time, the repeated, disciplined daily application of this nitric oxide-boosting walking routine does much more than just provide temporary relief. It actively induces long-term structural remodeling of the blood vessels, taking advantage of the body's innate neuroplasticity and vascular adaptability. Persistent, daily exposure to naturally elevated nitric oxide levels actively inhibits the pathological proliferation of vascular smooth muscle cells, and profoundly suppresses the localized expression of inflammatory cytokines and adhesion molecules that are the primary drivers of plaque formation and arterial calcification. In essence, by simply optimizing the rhythm and pathway of the breath during mild physical exertion, an individual can literally begin to dissolve the biochemical environment that fosters arterial hardening, gradually restoring a degree of systemic elasticity that allows the blood vessels to expand and contract with the youthful compliance they once possessed. This meticulously timed method stands as a monumental and revolutionary paradigm shift in geriatric cardiovascular care precisely because it entirely bypasses the need for intensive pharmacological interventions, which often come heavily burdened with a cascading array of detrimental side effects, complex drug interactions, and the frustrating reality of diminishing physiological returns over time. Instead of relying on synthetic vasodilators, organic nitrates, or highly potent calcium channel blockers that force artificial, often systemic and poorly targeted changes in vascular tone, frequently resulting in adverse events like sudden orthostatic hypotension, dizziness, and falls in the elderly. This breathing and walking protocol leverages the body's fundamental evolutionary physiology to restore systemic elasticity safely from the inside out. To fully maximize the absolute efficacy of this physiological intervention, however, the underlying biochemical machinery must be robustly supported through strategic and highly specific nutritional considerations, specifically focusing on the enterosalivary nitrite-nitric oxide pathway, which serves as a crucial, independent backup system for nitric oxide generation when traditional endothelial function is severely compromised by age. Consuming a diet meticulously rich in naturally occurring dietary inorganic nitrates, predominantly sourced from deeply pigmented vegetables such as red beetroot, dark leafy arugula, spinach, and celery, provides the vital raw materials necessary to fuel this alternative pathway, creating a beautiful synergy between diet, breath, and movement. When these nitrate-rich foods are chewed and swallowed, oral commensal bacteria residing on the crypts of the tongue efficiently reduce the ingested nitrates into nitrites, which are subsequently swallowed in the saliva, absorbed into the systemic bloodstream from the gut, and ultimately converted into active nitric oxide specifically in the hypoxic, highly acidic conditions characteristic of chronically constricted, oxygen-starved peripheral tissues during exercise. Furthermore, the vigilant preservation of this endogenous nitric oxide, once it has been synthesized, is just as critical as its initial production, necessitating a daily nutritional protocol richly abundant in potent, naturally occurring antioxidants designed to neutralize dangerous reactive oxygen species like the highly destructive superoxide anion. When elevated levels of unmitigated superoxide interact with the delicate nitric oxide molecule within the vascular environment, the two immediately combine to form peroxynitrite, a highly volatile and destructive oxidant that not only instantaneously depletes the amount of bioavailable nitric oxide required for vasodilation but also inflicts profound oxidative damage upon the endothelial lining itself, thereby actively accelerating the exact arteriosclerotic and calcification processes this entire walking protocol tirelessly seeks to reverse. Therefore, equipping the elderly body with a robust shield of antioxidants, specifically generous amounts of vitamin C, vitamin E, and diverse, complex polyphenol found abundantly in dark forest berries, green tea, pomegranates, and raw cacao, ensures that the massive wave of nitric oxide generated by the nasal breathing and sheer stress of walking survives long enough within the bloodstream to reach the target calcified arteries and exert its profound vasodilatory and healing effects. The psychological and neurobiological dimensions of this practice are equally profound and intricately linked to the overall success of the physiological outcomes, as the deliberate, mindful synchronization of nasal breathing with the physical rhythm of walking exerts a powerful, immediate, and measurable influence on the autonomic nervous system, specifically by modulating vagal tone and aggressively down-regulating chronic sympathetic hyperarousal. Chronic physiological and emotional stress, an omnipresent specter in modern life that often intensifies with the compounding anxieties of the aging process, triggers the relentless, continuous release of potent stress hormones, primarily circulating catecholamines like adrenaline and noradrenaline, alongside elevated baseline cortisol levels. These neurochemicals act as incredibly potent systemic vasoconstrictors, actively opposing and overpowering any attempts at vascular relaxation, effectively locking the peripheral arteries into a rigid state of chronic defensive constriction, heavily prioritizing blood flow to the core organs and skeletal muscles required for a literal fight or flight response that never actually materializes. Conscious, rhythmic, diaphragmatic nasal breathing, driven by the steady, unhurried cadence of mindful walking, acts as a profound mechanical intervention into the stress loop, directly stimulating the afferent fibers of the vagus nerve, which swiftly signals the brainstem to shift the entire organism from this destructive sympathetic dominance into a restorative parasympathetic rest and digest state. This profound neurological shift instantaneously decreases the resting heart rate, gracefully lowers systemic blood pressure, and universally dampens the systemic biochemical alarms that drive chronic vasoconstriction, thus creating the absolutely perfect, deeply relaxed neurophysiological environment for nitric oxide to enact its vasodilatory magic unhindered upon the peripheral vasculature. Beyond the easily measurable physiological metrics of blood pressure and tissue perfusion, Mastering this nitric oxide-boosting walking technique offers a deeply profound psychological transformation for the elderly demographic, systematically replacing prevailing feelings of physical frailty, inevitable medical dependence, and helpless decline with a vibrantly renewed sense of personal agency, bodily autonomy, and psychological empowerment. When an aging individual fundamentally realizes and practically experiences that they hold the literal physiological power to alter their own internal biochemistry and physically force open their own calcified, failing blood vessels simply by purposefully changing exactly how they breathe while they walk, it entirely shatters the culturally ingrained narrative of aging as a strictly passive, unmanageable slide into inevitable immobility. The execution of this technique, however, requires meticulous, focused attention to physical posture and biomechanics to ensure maximum efficacy, demanding that the practitioner actively maintains a proud, upright spinal alignment with the shoulders gently pulled back and down. This specific postural correction naturally and mechanically opens the thoracic cavity, allows for the optimal downward expansion of the respiratory diaphragm, and explicitly prevents the mechanical respiratory restriction and shallow upper chest breathing inherently caused by the kyphotic, hunched posture that is unfortunately so common and detrimental in advanced age. Furthermore, the mechanical foot strike during the walk must be highly intentional, smooth, and deliberately controlled, executing a perfect rolling motion from the heel strike seamlessly through the midfoot and actively pushing off with the toes, an action that specifically maximizes the mechanical efficiency of the calf muscle pump and ensures a steady, powerful, and rhythmic generation of endothelial shear stress along the entire length of the lower extremity arterial tree. The precise breathing cadence must be carefully and intelligently titrated to the individual's current aerobic capacity and baseline cardiovascular health, starting with a highly conservative, easily manageable ratio to prevent breathlessness or panic, such as inhaling smoothly and quietly through the nose for 2 comfortable steps and subsequently exhaling softly and completely through the nose for 2 steps. As lung capacity, cardiovascular fitness, and diaphragm strength inevitably improve over weeks and months of highly consistent daily practice, this ratio should be gradually and systematically progressed to a 3-to-3 or even a 4-to-4 step ratio, deeply expanding the volume of nitric oxide harvested from the sinus cavities with every single respiration. It is absolutely, unequivocally imperative that the mouth remains firmly closed and the jaw relaxed throughout the entirety of the exercise, as any instance of mouth breathing completely and entirely bypasses the paranasal sinuses, failing utterly to harvest the crucial nitric oxide reservoir, and instead brutally introduces cold, unfiltered, unhumidified, and unsterilized air directly into the delicate lung tissue. This sudden influx of harsh air via the mouth can easily trigger mild reflex bronchoconstriction, increase insensible water loss leading to localized airway dehydration, and subtly re-trigger the very sympathetic stress response that the walking practice is specifically designed to quietly dismantle. The systemic benefits of incorporating this profoundly precise daily practice extend far, far beyond the successfully targeted peripheral arteries in the legs and arms, radiating outward to profoundly impact cerebral blood flow, preserve cognitive function, and aggressively maintain the structural integrity of the microvasculature intricately perfusing vital, life-sustaining organs such as the kidneys, the heart muscle itself, and even the largest organ of the body, the skin. Enhanced cerebral perfusion, strongly driven by the systemic vasodilation and the radically increased efficiency of oxygen delivery, dynamically facilitated by the constant presence of nasal nitric oxide, acts as a highly powerful neuroprotective mechanism. By ensuring that the highly metabolically active tissue of the brain receives a constant, luxuriant, and unimpeded supply of circulating glucose and oxygen. This practice actively aids in potentially delaying the insidious onset of vascular dementia, clearing brain fog and mitigating general age-related cognitive decline, effectively keeping the aging mind as sharp and resilient as the newly elasticized blood vessels. Ultimately, this holistic, physiologically elegant integration of perfectly synchronized nasal breathing and gentle, rhythmic physical movement represents the absolute pinnacle of physiological optimization for the aging body, offering a deeply scientific, undeniably evidence-based, yet elegantly simple and highly accessible daily practice to actively and successfully combat the seemingly inevitable stiffening of the human vascular system. By persistently, daily forcing the biochemical vasodilation of deeply calcified peripheral arteries through the strategic, intelligent harvesting of one's own endogenous nitric oxide, the elderly can actively reclaim their systemic elasticity, fiercely maintain their independent, pain-free mobility, and fundamentally, radically rewrite the entire trajectory of their cardiovascular health without being hopelessly tethered to the pharmaceutical interventions that currently heavily dominate the landscape of standard geriatric care.